Hello everyone, welcome back to the another session in Principles of Programming Languages. The next topic is about type checking, strong typing and type compatibility. So this topic you'll find in second unit. Now, what is type checking? So basically type checking is what? It's an activity of ensuring the operation and an operator are compatible type. Now let's understand through an example. Suppose I have initialized a with integer data type and I have taken the other variable which is integer data type. Now, so these are what your operands. Now with this operands, I am going to perform some operation which is addition operation. Now what is type checking? It's an activity of ensuring that the operation, addition operation of an operator plus are of compatible type. Now we will be going to check this way. Now what is compatible type? Compatible type can be a legal one or it can be a rule of the implicit declaration or implicit rule of the particular language. I'll give an example. The other example, if I wanted to perform addition in between integer and a float in Java, then the answer of operation will be floating point, correct? So this is what it is called as coerced. Coerced is what? If an integer variable and a float variable are added in Java, the value of the variable is coerced to floating point. Now come back to the other one, which is type error. What is type error? When the operator and the operand are not appropriate type, then it is an type error. So now we'll talk about type checking. So what is type checking? Basically type checking are two types. The one is static type checking and the other one is dynamic type checking. Now let's understand through an example. If all binding variables to types are static in language, then type checking can nearly always be done statically. Now what is dynamic type binding? Dynamic type binding requires type checking at runtime, which is also called as dynamic type checking. Now let's take the example of some programming language, which is, I'm taking an example of JavaScript and PHP. Because of their dynamic type binding, allow only dynamic type checking. So it is better to detect errors at compile time than at runtime, because the earlier correction is usually less costly. Now, we'll take an example respective to other programming languages. Type checking, basically it is a complicated when a language allows a memory cell to store values of different types during the execution. Such memory cells can be created with ADA variant of records and C and C++, usage of unions and the discriminated unions of ML, Haskell and F sharp. In these cases, type checking, if done, must be dynamic and requires the runtime system to maintain the type of the current value of such memory cells. So even though all variables are statically bound to types in languages such as C++, not all type errors can be detected by static type checking. Now let's talk about strong typing. So strong typing is what? A programming language is strongly typed if type errors are always detected. This question has came in the last year examination paper for 2 marks. Now, what is strongly typing? That's what the question, and you can write the definition. So, definition and with one language example if it is needed. Now, let's continue. This requires that the type of operations can be determined either at compile time or at runtime. So, whatever time may be of it is, whether it is of compile time or it is runtime, we should be in a position, that compiler of the particular language should be in a position to check the type errors. Now, so we'll take an example for the same. Strong typing examples or strongly typing examples are ADA is nearly strongly typed. and it is only nearly strongly typed language because it allows programmers to breach the type checking rules by specifically requesting the type checking be suspended for a particular type conversion. And C and C++ are not strongly typing languages. Now, why those are not strongly typing languages, C and C++? Because we'll use union types which are not type checked. So, due to union support in C and which we are not type checked, C and C++ are not strongly typed because you cannot detect all time errors. That's what it is not strongly typed. Now, ML is strongly typed, F sharp is strongly typed, and Java and C sharp also strongly typed. Now you can ask me a question. C and C++ are not strongly typed, but you are saying that C sharp is a strongly typed. Yes, it is true. Though it is, although they are based on C++ or strongly typed in the same sense of ADA programming language. These are what about strongly typing languages, or else you can say it is an example. Now we'll talk about type equivalence. What do you mean by type equivalence? Basically, type equivalence is what when you wanted to when you have find some correlation of these types. Let's say that integer is a variable and float is a variable. Now if A and B perform some operation, let's say it is subtraction operation, the expected result will be correlated with floating point of value. Now, correlation of these types is raised. So, the issue is not type compatibility but type equivalence. That is, two types are equivalent if an operand of one type in an expression is substituted for one of the other type without correlation. Type equivalence is a strict form of type compatibility. Compatibility without correlation. Now, so there are basically of two types. The first type is what? Name type equivalence, and the second is what? Structure type equivalence. Name type equivalence means the two variables have equivalent types if they are defined either in the same declaration or in the declaration that use the same type name. So structure type equivalence is what? Means that two variables have equivalent types if their types have identical structures. There are some variations of these two approaches and many languages use combinations of both. So this is about type equivalence. That's it. Thank you all.